Hello and welcome to today's session. This session focuses on learning outcome 3 discuss and evaluate the data collected and the conclusions drawn. Have you ever wondered how data from chemistry experiments is analyzed and evaluated? In this presentation, we will explore how to assess the quality of experimental data, identify limitations, and suggest improvements to ensure that robust and reliable conclusions can be drawn. Reliability in experiments means consistent results upon repetition. We improved reliability by repeating measurements and using consistent methods. Immediate recording helped reduce memory errors. The rate of reaction experiment was highly reliable, showing clear trends. Chromatography reliability varied with solvent and paper types. Accuracy involves how close results are to true values. Human reaction time affected accuracy in the rate of reaction experiments. pH accuracy depended on probe calibration and consistent rinsing. Chromatography accuracy relied on precise distance measurement. Overall, accuracy was sufficient to identify trends. Validity checks if the experiment tested its intended purpose. Rate of reaction validity relied on consistent magnesium size and acid volume. pH curve validity required equal volume additions and stirring. Chromatography validity depended on maintaining solvent levels. Validity ensured the experiments tested their hypotheses. The rate of reaction experiment showed that higher concentration increases reaction rate. This conclusion matched collision theory and was supported by consistent data trends. Small errors didn't affect the overall outcome. The trend was clear and reliable. The conclusion strength was rated high. pH curves demonstrated that weak and strong acid-base combinations differ in equivalence points. Weak acid with strong base had a point above pH 7. Strong acid with weak base had a point below pH 7. The curves also showed buffering behavior. The conclusion was scientifically valid. This strengthened the conclusion of ink being a mixture. Experimental techniques affected chromatography results. The conclusion strength was rated medium. Errors in experiments can arise from various factors. Stopwatch delays and unequal magnesium sizes affected reaction rates. pH probe calibration and stirring consistency influenced pH readings. Chromatography errors included spot size and solvent level. Identifying errors helps improve reliability. To improve data quality, use precise measuring tools like gas syringes. Calibrate pH probes and use magnetic stirrers for consistent mixing. Apply smaller, controlled spots in chromatography. Repeat experiments for better reliability. These improvements will strengthen data and conclusions. Overall, the experiments provided data that matched scientific theories. Rate of reaction trends were strongest, while pH curves needed careful measurement. Chromatography confirmed mixtures but required precise technique. With improvements, data reliability and conclusion strength will increase. Accuracy was key to identifying scientific trends. Human timing errors affected rate experiments. pH readings depended on probe calibration and mixing. Chromatography accuracy relied on precise measurements. Overall, accuracy supported valid conclusions despite minor limitations. Anomalies are results that don't fit expected patterns. Identifying them helps improve reliability. In rate experiments, timing errors caused anomalies. pH anomalies arose from probe contamination or poor mixing. Chromatography anomalies resulted from spot size or solvent level issues. Suitability depends on accuracy, reliability, and validity. Rate of reaction procedure showed clear trends but had timing limitations. pH curve procedure required controlled conditions for accuracy. Chromatography was simple but needed precise technique. Overall, procedures were suitable but could be improved. To enhance reliability and accuracy, use precise equipment like gas syringes. Calibrate pH probes and use smaller volume increments in titrations. In chromatography, apply controlled ink spots and maintain consistent solvent levels. These modifications will strengthen conclusions. Key improvements include precise measuring tools and controlled variables. Increasing repeats and using calibrated equipment will reduce anomalies. These changes will enhance data quality and conclusion strength. Reliable data supports valid scientific conclusions. Consistent procedures are essential for accuracy. Conclusion: enhancing the accuracy and reliability of experiments strengthens the validity of the conclusions drawn, ensuring that the results are both trustworthy and scientifically robust. Should you have any questions, please contact us via WhatsApp at 074843616888. Our team will gladly support you. Thanks for your time, and see you soon.